the previous episodes, we created our Orders API to handle orders and connected it to the Payments API using Feign. Now we move on to actually saving data in MongoDB. Since we always aim to follow best practices, we will adhere to domain-driven design principles and separate our domain model from database implementation details. Welcome to Microservices in the Cloud with Jay, where we explore the exciting world of microservices, cloud computing, and modern IT architecture. Today, I will show you how to structure your packages, configure Spring Data MongoDB, and connect to the database. Let's dive in. If you haven't done so yet, run IntelliJ and open the main POM XML file in the Orders API project. In the Dependencies section, add the following dependency. Thanks to this, our application will be able to use annotations like document, the Mongo repository interface, and other Spring Data MongoDB features. Run Maven install and synchronize the project to update dependencies. In the Resources folder, open the application YAML file and add the configuration pointing to the address of our database. Under Spring, Data, MongoDB, and then URI, specify the database address. Port 27017 is the default for MongoDB. Thanks to this, Spring Boot will automatically connect to the Orders DB database when our microservice starts. Of course, for the service to connect to such a database, it needs to be installed beforehand. There are at least 3 ways to handle this. Local installation. You download the latest version of MongoDB from MongoDB.com and install it directly on your operating system. Running MongoDB in a Docker container. You can use the official MongoDB image available on Docker Hub at hub.docker.com. Using MongoDB Atlas. MongoDB Atlas is a fully managed cloud service that allows quick startup and easy scaling of the database. You can integrate it easily with AWS and other clouds like GCP or Azure, making it convenient to manage your database without installing and configuring a local server. You will find links to all these sites in the description of the video. We will devote more time to MongoDB Atlas and AWS in the next episode, but for now we will focus on connecting to the database on localhost. I chose the second option. I downloaded the Docker image and ran the database locally that way. If you use the standard local installation, all subsequent steps, including configuration, will look identical. Now that we have a database, in the main orders package we create 2 new packages, domain, where we will place domain classes such as order or order ID, and infrastructure DB, where elements related to persistence will be located, such as OrderDocument, the mapper to MongoDB, and the Spring Data repositories. This way, we have a clear division between business logic, the domain, and details related to the database, the infrastructure. Let's move on to defining our domain. First, we will prepare the representation of the database identifier in the domain layer. In the domain package, we create a record named Order ID. This record takes a unique identifier of type string. In the constructor, we ensure that the provided value is not empty or null. If it's invalid, we throw an exception. Then we define a method that generates a new ID, which uses the UUID class, known from the previous video. By doing so, we've created a dedicated type for the order identifier instead of using just a raw string. The generated UUID eliminates the need for auto-incrementation, which can cause problems in microservices environments. Wrapping the identifier in a dedicated type like order ID aligns with domain-driven design principles. By doing so, we clearly express the domain intention. Instead of using a general type like string, we explicitly indicate that the value represents an order identifier. This approach improves code quality and better reflects the business reality in the domain model. It's also important that we generate the identifier directly in the identifier class. This keeps all the logic related to the order identifier in one place, improving code cohesion and maintainability. Additionally, we centralize the validation logic, so we can ensure in one place that the identifier is valid, which reduces the risk of errors. Moving on, let's create a new class in the domain package called order. This will be our domain model. We don't use any database annotations here, keeping the code clean and easily testable. I chose a class instead of a Java record because, in the context of DDD and future expansion, a class is better suited to a domain model that may evolve. Now we will handle the elements related to persisting data in MongoDB. In the infrastructure DB package, we create the class OrderDocument. This class is closely tied to MongoDB, so we keep it in the infrastructure DB package to ensure our domain remains independent of database frameworks. After preparing the basic Lombok annotations, I use the document annotation where I specify the name of the collection to be found in the database. We will return to the topic of NoSQL databases soon, but first, I will add a few more fields to the document class. First, I add the ID field, which is auto-generated by MongoDB. Then, I keep the existing order ID and amount fields. Besides the basic constructor, we could use one that does not expect the ID generated by MongoDB. Since we won't set it, but we still want to create an object of the OrderDocument class, it's good to prepare a dedicated constructor. Returning to the topic of NoSQL databases, now that we have structured our OrderDocument class, let's see how this translates into a MongoDB collection. A collection is like the equivalent of a table from SQL databases, except that it does not store records but documents. For someone familiar only with SQL databases, it's important to understand that in a NoSQL database like MongoDB, which uses the document annotation, data is organized differently. Instead of tables, we have collections, and instead of rows, we have documents. Each document is a set of key-value pairs, which can be nested and more complex than the flat structure of SQL tables. This flexibility allows for a more dynamic model of data that can change as new fields are added or removed without the need to alter an entire table schema, which is a common requirement in SQL databases. This approach is particularly useful when dealing with varied and rapidly changing data. Let's go back briefly to the order class. Here, I'm adjusting the type of the order ID field, changing the field's name from ID to order ID, because simply calling it ID might confuse it with the auto-generated identifier by MongoDB. Next, we create the class order mapper. This mapper is responsible for converting between the domain object order and the order document that is intended for reading and writing data to MongoDB. In the order mapper class, I need two methods, one that maps the domain object order to the MongoDB document order document. Call it to document. And another that maps the order document back to the domain object order. Call it to domain. With the order document model ready, we can now create the database layer. In the infrastructure DB package, we create the interface Mongo order repository, which extends the base Mongo repository interface. This way, we automatically gain access to ready-made methods for CRUD, as well as pagination and sorting. In the definition of the interface, we specify our OrderDocument class and the type of the key, here, string, which informs Spring data about the document type and how it should be handled in the MongoDB collection. Notice that by looking inside the Mongo repository interface, we can easily see where it comes from. As you can see, it's part of Spring data for MongoDB. In the service package, we modify the order service class. In this service, you can clearly see all the steps: generating an order ID, calling the payment client, and then saving the object to the database using the Mongo order repository. I will now run the project in debug mode. Previously, I also ran the microservice payments API because the method process order communicates with that microservice, implemented in the previous video. Notice the logs in the console that come from the MongoDB package, indicating a successful connection to the database on port 27017. I'll set an endpoint in the process order method and send a request from Swagger. In the field order ID, I provided an example UID to demonstrate that its arrival does not affect what's actually saved in the database. Remember the value of the amount field, 230. In a moment, this value should appear in the database. I send the request and catch the process at the breakpoint we set earlier. Let's continue the process, going through each line of code. As you can see, a unique UUID is generated by the generate method. Next, a request is sent to the payments API, and the process moves to creating a domain object of the order class. Of course, the order ID has the generated ID and the amount is 230. Next, mapping takes place to an entity object order document, which we then save to the database using the Mongo order repository. Finally, the method ends by returning the text we prepared. Notice that the saved document has an ID generated by MongoDB. This is an independent technical identifier fully managed by Mongo. Of course, our generated order ID and the value amount are also visible. Finally, we need to check whether the data was correctly saved to the database. We can do this in several ways. Naturally, you can install an external client for the MongoDB database, but even IntelliJ itself allows a simple connection to the database via the built-in tool database tools and SQL. According to its description, This tool provides integration with various database providers, including MongoDB. I already have this plugin installed, but if you don't, you can install it right from the window shown on the screen. Once the plugin is installed, just go to Tools, Windows, Database, where you can easily configure a data source. Note that sometimes after opening the Data Sources window, an entry appears in the Problems section. By going there, you can see information about the specific issue. We can see that currently the MongoDB driver is missing, which we can solve by clicking Fix. Then we can click OK, because the correct host and port are automatically set. As you can see on the right side, the data source was added as planned. You can now click on localhost and select our database OrdersDB. Next, just hit Enter, and you can navigate to the Orders Collection view. In the central area, you see the result of the Feign method, the document saved in the Orders collection. All the data matches what we saw in the code, confirming that the save to the database was successful. Okay, the Database Tools and SQL plugin is quite handy for casual checking of data in a local database, but you'll agree it doesn't look professional enough for everyday database browsing, especially in TST or prod environments. You definitely need a dedicated tool to browse MongoDB documents. You have a few options here. If you need a free solution, I recommend Studio 3T Free for MongoDB. It's a stripped-down version of the paid Studio 3T, which offers a really wide range of possibilities. The free version is perfectly sufficient for browsing documents. Another option is the popular MongoDB Compass. It also has a free version, but personally, I don't like it as much as Studio 3T. The last option I need to mention is NoSQL Booster. It's an advanced tool with a simple interface, which I use daily on large-scale projects. However, getting the full benefits of its features requires purchasing a license, which is not the cheapest, though not exorbitantly expensive either. To sum up, you have several tools to choose from depending on your needs and budget. If you're looking for a free solution, Studio 3T Free or MongoDB Compass should meet your expectations. If you need something more advanced and professional, it's worth investing in NoSQL Booster or the full version of Studio 3T. Which tool do you use every day? Let me know in the comments. Let's assume you also pick Studio 3T Free. After creating a free account in the Studio 3T portal, just paste the connection string that we defined in application YAML into the tool. Then you can change the connection name, which only affects how this connection is displayed in Studio 3T. The rest of the settings can remain unchanged. In the next step, click through the short wizard. Expand the OrdersDB collection and double-click its name. In the central panel, you will see the contents of your collection. You have to admit it looks much more professional than in IntelliJ. That's all for today. In this episode, we separated our domain model from database details, keeping to DDD principles. We added the dependency for Spring Data MongoDB, configured application YAML, and connected to the database on localhost. We created the domain package with classes order and order ID, and the infrastructure DB package, where we placed OrderDocument, the mapper, and the repository. In the end, we tested it by sending data to MongoDB, and we introduced tools to browse the database, from the IntelliJ plugin to Studio 3T, MongoDB Compass, and NoSQL Booster. In the next episode, we'll devote time to MongoDB Atlas and AWS, making it simpler to manage and scale the database in cloud environments. And which tool do you use for browsing MongoDB? Let me know in the comments. See you next time.